Bismillahirrahmanirrahim. Assalamualaikum and hi everyone. So today I will explain about Lecture 3 of subject Computer Organization and Architecture part 2C. Okay.
Okay.
So I will introduce my name. I'm Norirham bin Sibi and my friend.
My name is Luqman Al-Hakim. All right.
Okay.
Okay, so I will explain the question. So the question is basically a combination from question 1, program 1 and program 2 with a condition where if the user press number 1, they will run the program 1, and if the user select number 2, it will run program 2. And it must have the output shown. Yeah. If the user press Y, it will return to the main menu, and if they press N, it will exit the program. All right, let's look directly at the executable code implementation starting at main prop. The label show menu functions as our structural home base. The instruction call clear screen clears the terminal screen at the start of each cycle, directly satisfying the visual refresh requirement for the prompt.
Okay. To render the selection screen as seen, we run move the EDX offset menu title followed by call right string. This pass the pointer of our menu text into the EDX. Allowing the console to output the interface strings. Okay.
Immediately after, call readDec halts execution until the user inputs an unsigned decimal choice. This value is captured automatically into the EAX register.
To execute the branch condition specified by the assignment sheet, we utilize condition comparison command. This is the commands. If EEX match 1, routes the flow to the hexagon calculator, menu 1. If it's match 2, if it route to the array calculator, and any other numerical or invalid choice triggers jump show menu, creating an unconditional loop back to the interface starts.
All right. So now let's go to the section where the program 1 starts. So when option 1 is executed, the runtime branches to perihex look at. It clears the interface and uses write string alongside readDec to query and capture inputs for both hexagon 1 and hexagon 2 site lengths, copying the register values into variables site hex 1 and site hex 2 to match figure 3.2 from the document.
The prompt states that the parameter must be evaluated specifically using loop and adds instruction, explicitly forbidding multiplication. To set this up, we load our loop counter register with move ECX 6. Since hexagon has 6 structural sites, and we reset our accumulator via move EX 0.
Right. So inside the L1 block, add EAX site HEX1 incrementally sums the site length. The loop L1 instruction handles counter decrement and jump control inherently until ECX reaches 0. The output is moved to parameter hexagon 1, and an identical iteration sequence runs under L2 for the second hexagon.
Both distinct parameters are then aggregates with add EX parameter hexagon 2. This one. The program displays these totals on separate lines using right decimal and call CRLF to accurately match the output formatting in the question. Before running jump as question continue to bypass the array module.
So let's go to where the program 2 is at. So if choice 2 is selected, the application transitions to call sum odd even to sum array elements across even versus odd indices as modeled in figure 3.3. We initialize our loop count with move ECX 6 and reset our base offset index pointer with move EDI 0.
Within input loop, call read decimal takes the decimal integer sequentially and move hello EDI ES save them into the array because we are dealing with the word variable. Um, we advance our pointer using ADI type keyword to step forward exactly 4 bytes in memory for the subsequent loop phase. Come on.
Subsequent loop. Oh, dah lah. Next is the
Yeah.
core mathematical constraint of the prompt, isolating even and odd index spaces. For even loop, which representing indices 0, 2, and 4, we load our counter with move 3 to ECX and set our source index register move 0 to ESI.
Inside this block, EAX, hello ESI, extract and accumulate the target value. To skip the odd position and isolate the next even element, we perform at ESI 8. We step forward by 8 bytes because skipping an element requires jumping across two the word. Fill 2 times 4 bytes that equal to 8 bytes. The total is archived into total event. Total.
Nice. Next, the outlook routine follows an identical programmatic trajectory for indices 1, 3, and 5. The only difference is that our tracking index is initialized to byte position 4 with move ESI 4 to point to index 1. The result is stored in total odd. Both variables are then printed out using standard Irvine library commands to mirror figure 3.3 from the document.
Okay, for the loopback verification and termination, both computational segments converge at the ask continue. This one. Routine to address the prompt's final execution clause. The call read string, read character command capture a single keystroke from the user directly into the AL. Register without waiting for a carriage return and call write character echoes it visually onto the terminal.
Okay, next we execute a character match comparison using compare ALY. If the user explicitly press the Y key, the conditional statement JE show menu triggers routing execution back to the primary menu loop.
If they enter N, mana? Sebelah. Okay. If they enter N or any other termination key, the code execution falls through. It loads our sign off notification string into EDX. Calls write string to output thank you. Thank you, bye. As demonstrated in the question, and finish execution cleanly via the exit directive. The main in and procedure and main line formally close out the assembly source file.
So now let's proceed to the program. All right, so let's choose to calculate the perimeter hexagon first by pressing 1. And then let's enter our input, which is for hexagon 1 is 21. And for hexagon 2 is the 32. So we can now get the output result of perimeter hexagon 1 and 2 are 126 and 192, with total perimeter hexagon 1 and 2 is 318. So to get back to the main menu, we need to press Y.
Okay.
Alright, so now we are back to the main menu. Let's choose the second program, which is to calculate sum for odd or even. Let's press 2. All right, so now it will ask for the integer input. Now we can see the result sum hello index. So the sum hello even index location is 90, and for sum hello odd index location is 105. So to exit the program, we simply just press N. Yes. So now at the command prompt, thank you by text will be displayed and will exit the program. So that's all from us. Thank you. Assalamualaikum.